Picture yourself driving across a ribbon of steel suspended so high above the ground that the clouds drift past your windows. Far below, the Earth disappears into a dizzying abyss. This isn't a scene from a futuristic film or a fantasy concept. It's real. In China, a bridge rises to an altitude so extreme that it redefines what humans thought was possible in engineering. This is the Huajiang Bridge, inaugurated in September 2025, a structure that instantly claimed its place in history as the highest bridge ever built on Earth. Its deck soars an astonishing 2,051 feet above the water below, nearly twice the height of the Eiffel Tower, earning it global recognition and transforming it into a new symbol of modern engineering ambition. But the Huajiang Bridge is not remarkable only for its record-breaking height. It spans one of the most treacherous canyons in western China, a place where violent winds, sheer cliffs, and dense, persistent fog forced countless previous projects to be abandoned before they even left the drawing board. And yet, rising above this hostile landscape, Chinese engineers went even further. At the top of one of its towers, they built a cafe, floating above the canyon, illuminated among the clouds. It sounds like science fiction, but it is entirely real. In this video, we'll uncover how this bold vision was transformed into one of the most extreme infrastructure projects ever attempted. But before we begin, don't forget to like the video and subscribe to our channel. The journey of this record-breaking bridge began in one of the most rugged regions in all of China. Guizhou Province is known for its severe terrain. More than 92% of its area is composed of high mountains and plateaus, and between them lie 8 major rivers and countless tributaries that carve deep valleys, making transportation and trade a constant challenge. For this reason, when building the Liuji-Anlong Expressway, connecting Liupanshui to Anlong County, the route was forced to pass through the dangerous convergence point of the Beipan River, inside the Huajiang Canyon. This is how the Huajiang Bridge came into existence, a structure whose importance goes far beyond that of an ordinary bridge. During the study phase, engineers faced 2 options with similar costs. One option was to build a gentler access road, positioning the bridge closer to the mountaintop. The second option was to build the bridge lower down, but crossing a series of steep slopes and long tunnels. In the end, the challenge of extreme height was chosen. However, the V-shaped canyon created a distance of more than 4,593 feet between the 2 rocky edges. At this scale, all other types of bridges proved unfeasible. The world's tallest rigid-frame bridge could not span the gap. The largest arch bridge could not reach the required distance, and not even the biggest cable-stayed bridge was capable of crossing the necessary span. Only a suspension bridge, with an ultra-long main span, could meet such extreme engineering requirements. But how do you build a colossal bridge in such an unforgiving landscape? In principle, there are 3 stages. First, build the 2 towers, then position and firmly anchor the 2 main cables, and finally, suspend the bridge deck using the hangers. That, however, is only the theory. In practice, everything is far more complex. The Huajiang Bridge rises 2,051 feet above the river and stretches approximately 4,659 feet across the canyon. Including its towers, the structure reaches a height comparable to the tallest buildings ever constructed by humankind. With dimensions this extraordinary, it becomes clear that the Huajiang Bridge is not just large on paper. It requires a construction process far beyond conventional infrastructure standards. In addition to the difficulties imposed by the terrain, the foundation presented another major challenge. The base of the tower had to be drilled deep into weathered rock layers filled with fractures and groundwater, where even the smallest mistake could lead to serious accidents. To overcome this problem, engineers used a special pile system, driving 24 massive concrete piles into the ground, combined with seismic steel reinforcements, ensuring that the tower could withstand decades of operation. Once the foundation stage was completed, the next step was to erect the 2 main support columns of the bridge. The two towers, one 860 feet tall and the other 673 feet, serve as anchoring points for the entire cable system. They were built directly into the mountainside, hundreds of feet above the canyon. Together with the two main cables, each weighing more than 9,900 tons, these towers support the bridge like two gigantic pillars holding a ribbon in midair. Stability is essential, so the entire structure was reinforced with high-strength steel capable of withstanding strong winds, vibrations, and even earthquakes throughout its design life. However, for these towers to fully perform their role, the cable anchoring system at both ends of the bridge needed to be equally robust. The Huajiang Bridge's anchorages act as giant counterweights, firmly securing the two main cables to the mountains. On the Zhenfeng side, a gravity-type anchorage was solidly installed into the slope, with a total concrete volume of up to 214,500 cubic yards, forming an extremely stable resistance block. On the Guanling side, the anchorage was designed as a tunnel. Instead of placing a massive concrete block on the surface, engineers excavated deep into the mountainside and fixed the anchoring system directly into the natural rock, transferring all cable tension into the mountain itself. The reason for this choice is clear. Behind the tower on the Guanling side lies a steep mountain, but the available flat area is extremely limited. Using the mountain itself as a natural anchorage became the ideal solution, saving space and increasing the stability of the entire structural system. After completing the anchorages, the next step was installing the temporary catwalk, a suspended pathway between the two towers where workers would build the entire cable system. To launch the first pilot cable across the canyon, hundreds of feet deep, engineers used drones, making the process safer and more precise. With the pilot cable in place, the catwalk was assembled, creating the foundation for the most critical phase, constructing the two main cables of the bridge. Each main cable is composed of tens of thousands of high-strength steel wires, precisely twisted to form a structure capable of supporting tens of thousands of tons. On the suspended catwalk, workers installed each cable strand, with each strand containing 91 high-strength steel wires measuring 0.22 inches in diameter. These were tensioned from one side to the other under GPS supervision, maintaining an error of less than 0.08 inches. In conditions of strong winds and extreme altitude, controlling every movement was absolutely critical. After all 217 strands were installed, a special machine compacted and unified the wires into a circular cable, which then received multiple layers of protection against corrosion, weather, and vibration for decades. Only after completing these two main cables could the bridge move on to the next stage, suspending the deck. First, engineers installed the vertical hanger system, each one fixed to the main cable using special clamps capable of withstanding forces of thousands of tons. These hangers transfer the deck's load to the main cables and then to the anchorages. Next, the bridge's main girder, composed of 93 steel segments, was lifted one by one from the center and gradually extended toward both ends. Each segment, weighing hundreds of tons, was hoisted using a pulley system suspended more than 1,970 feet above the water and connected to the hangers by special load-bearing joints. During installation, engineers constantly adjusted cable sag, hanger tension, and the position of each segment to ensure the deck remained perfectly aligned without tilting or twisting caused by wind. Once all 93 segments were positioned and connected, the deck system was complete, transforming the suspended structure into a fully functional expressway. After construction was completed, the next step was to evaluate the bridge's real-world strength. In the load test conducted in August 2025, 96 heavy trucks with a total weight of 4,078 tons were used to assess load capacity and dynamic performance. More than 400 sensors recorded data on deformation, stress, and vibration, ensuring the bridge met the most stringent safety standards. This test not only confirmed its absolute safety but also demonstrated advances in real-time structural monitoring. Throughout the construction of the world's highest bridge, the team faced extreme challenges imposed by both nature and terrain. The Huajiang Canyon is known for its intense winds. Under favorable conditions, gusts can reach force 14 on the Beaufort scale, while construction must be halted whenever winds reach force 6 or higher to ensure worker safety. During the transport of steel girders, stabilization cables sometimes became tangled, forcing workers to manually realign them and balance forces between both sides of the canyon. Work began at 6 a.m. and often continued until after nightfall. Beyond wind and rugged terrain, the sheer volume of materials posed another major challenge. The Huajiang Bridge consumed approximately 574,000 cubic yards of concrete, the equivalent of 176 Olympic-size swimming pools. To reduce costs and protect the environment, engineers reused rock excavated during construction, crushing it to produce a high-performance mineral powder used as a supplementary material to replace 20% of the cement in each cubic yard of concrete. This approach not only saved cement and reduced costs but also gave useful purpose to waste materials, helping limit pollution and conserve natural resources. Thanks to these measures, the team overcame natural and geographical challenges, delivering the project sustainably and efficiently. After all the effort required to conquer mountains and cliffs, the bridge now opens up a new world for the region. In the past, traveling from the bridge area to the city of Guiyang took at least 3 hours. Today, the journey takes no more than 1.5 hours, saving nearly half the time. Faster travel makes daily life more practical for local residents and benefits thousands of people throughout the region. As a transportation project integrated with tourism, the Huajiang Bridge was designed from the outset to ensure both structural integrity and visitor experience. With expansive views, ideal altitude, and breathtaking scenery, both sides of the bridge feature safety guardrails and a special pavement coating that stabilizes the deck and allows adventure sports at extreme heights. Inside the steel girder, there's a visitor walkway that, if not intended for tourism, would serve only for maintenance, and its impact goes far beyond what meets the eye. By connecting to the G56 expressway, the bridge not only reduces travel time but also opens regional trade routes between China and Southeast Asia, attracting investment, creating jobs, and improving areas such as education, healthcare, and tourism, bringing the entire region closer to a more prosperous future. The Huajiang Bridge is not just a monumental engineering achievement, but the culmination of the intelligence, effort, and perseverance of Chinese engineers. From the first days of deep rock drilling, the concreting of the main tower shafts, the completion of the tower tops, the installation of transverse steel girders, the tensioning of suspension cables, to the fine adjustment of every locking component, each stage was filled with challenges and demanded absolute precision. Looking back at the entire process, the bridge seems to have grown day by day, from a mere idea on paper to a majestic reality spanning a deep canyon. The story of the Huajiang Bridge is not only the story of a world record, but also a testament to the transformation of Guizhou Province, which evolved from a remote and rugged region into an integral part of the modern rhythm of the 21st century. Did you enjoy the video? Leave your comment and your like, and see you next time.